Okay, you're going to go over the magic box for the high flow systems. What you need to know how to do this is when you deliver a high flow system meets or exceeds the patient's demand. Typically when we set up a high flow system, we want the total flow to be between 40 to about 45 liters per minute. That is what is going to the patient. So what we're going to do right now is we're going to set up a 28% trach collar. I'm going to show you a couple things with this. First of all is we need to figure out what liter flow to set our flow meter. So this is where you do the magic box. In the center you place the desired FiO2. You over here put the entrainment gas, which is our room air, and then here we set our source gas, which is wall oxygen at 100%. So then you do a cross subtraction, which is 72. You don't have to do the arrows, 7, which gives us a 7 to 72 ratio. What this means is for every 7 liters of oxygen that goes in, we will entrain, or the system will entrain using the Venturi-Bernoulli principle, 72 liters of air to dilute 100% oxygen down to 28% oxygen. So that is a little hard to work with. So let's try to get the oxygen down to 1. Before I do that, I'm just going to round that off a little bit. Sometimes you do want to, sometimes you don't. So since I want oxygen is 1, I'm going to divide both sides by 7, which comes out to be a 1 to 10 ratio. What that tells me is for every 1 liter of oxygen, I will entrain 10 liters of air, and liters to the patient will be 11. So basically all I did is 1 plus 10 is 11. Now, since I know that fact, and I want anywhere from 40 to 45 liters per minute, I've taken a few liberties with math. I know that 11 is going to go into 44 quite easily. So I'm going to shoot for 44 liters per minute. If I did 40, let's say I wanted to do 11 and I want to do the minimum flow, that's going to be 3, which is 33, which is then 7, bring down 7, and then that's going to be 6, 3.6. Well, it's kind of hard to set up a flow meter on 3.6, so I'm just going to go for 45. I want my total flow to be 45, 4, 44, 1, forget it. So I'm just going to go with 4 liters per minute. What this is saying that I need to set my flow meter at 4 liters per minute. Well, that is great. What would my total flow be? Total flow will equal 4 times 11 equals 44 liters per minute. Where did my 11 come from? My ratio over here. So in summary, if you want to get 40 to 45 liters per minute going to the patient, our FiO2 is 28% trach collar, source gas, entrainment gas, desired FiO2, cross, subtract, 7 to 72. I just simplified a little, made it a 7 to 70, divide both sides by your oxygen, I got a 1 to 10 ratio. For every 1 liter of oxygen, it sucks in 10 liters of air, so I know I have 11 liters per minute going to my patient. Then I take my total flow of 40 to 45. I did a couple maths. Which one did I want? You always want to air higher. So if I did this one, I said, no, I want it lower, 3. I would only have 33 liters per minute going to my patient, so I don't want that. So with this one, even 3.6 rounded up to 4. What is my total flow? My flow meter is set at 4. 4 times 11. 11 comes from over there. 4 times 11 equals 44 liters per minute. So currently I will take my trach collar, set the set the dial on 28% trait collar, put my flow meter at 4 liters per minute, I can then guarantee my patient will receive 28% trait collar at 44 liters per minute. That is the magic box.